It's nighttime in here. Today I'm going to present you the topic of how can we use computer software technology to analyze and develop agricultural machinery design. I'm currently working in University of South Australia in the School of Mechanical Engineering. In this presentation, basically, I'm going to talk about the software technologies and the hardware technologies available that makes agricultural machinery design more practical. So let's start. As you know, soil constraints the limit and the crop productivity. And in order to overcome soil constraints, we use a large variety of agricultural machineries. We use basically primary tillage tools like mower plow, disc plow, or some cultivators or deep reapers. As well as that, we use some fertilizers, spreaders to add fertilizer to the field. And the selection of suitable agricultural machinery is a very challenging job because you need to know what exactly your machine does so that you can get the maximum performance from your device. Generally, the machinery evaluation and designs are currently based on experimental knowledge. So what we do is basically we go to the field, test the equipment, and then analyze or give information about the performance of the machinery. Or after designing the machinery, then we go to the field and do some evaluation. If we can simulate the interaction between soil and agricultural machinery, then it helps us to design better machineries, and also it helps us to evaluate the performance of our machinery without performing these time-consuming and expensive field tests. There are some methods used for machinery design, such as analytical methods or continuum numerical techniques. But these methods are currently limited because these methods can only give you information about the forces. Their ability of giving the soil movement or the product movement is quite limited. So what we can do to sort it out? So as a method, we can use the discrete element method, which is a particle-based method. It's a discontinuum method, and its main advantage is that once the particles are in contact, then after the contact, we can follow this particle until the end point. So this helps us to calculate the soil movement and as well as the forces, which is a great tool. So in this slide, you can see some formation. If we have like 3 particles, as you can see here, once they are in contact, the contact between the particles are calculated in these surfaces, and then we can integrate these equations, and then we can calculate the force and acceleration of the particle's position. So this is basically how DEM works. In order to run a suitable and effective simulation, what we should do is to determine a contact model, because all the contacts are based on mathematical equations. So basically, if the machinery we use is a soil, we prefer a hysteretic spring contact model. If we are designing different systems such as olives, almonds, and something like that, then we can rely on the Hertz-Millen method. So what are the steps to run a successful simulation? The first thing we need to do is to create the exact shape of the particle, or a very closer shape of the particle. To do so, we can use the spheres because of their computational simplicity, and then we can combine them, and we can get the desired particles. After that, we need to carry out a calibration process, because we are not using exactly the same shape or exactly the same size. So this means that we need to calibrate our particles so that they behave exactly like the real particle sizes. To do so, what we can do, we can run an angle of repose test. This test helps us to, as you can see here, helps us to determine the shape of the pile. So once we have this pile, as you can see in here, on the left hand side is a sandy soil, on the right hand side you can see a cohesive soil. Then we can get this angle, and by changing or tuning in the numbers, we can get the same particle bulk material. The second test we can do is a penetration test. So basically, we can mimic a penetration test. We can penetrate a coin into the soil, obtain the forces, and then we can simulate this so that we have the same force results. Another method is a direct calibration. So if we have enough facilities, what we can do, we can run the tool, we can get the soil movement and the soil forces, and then we can play with the software so that we can get the similar behavior. After that, we can use the statistical method of design of experiment to get the right numbers. After determining the numbers and creating our soil bin or the material factory, what we should do is to obtain the CAD geometry of the part. Generally, we should get this from the agricultural machineries, but machinery manufacturers. But generally, these manufacturers are not really keen to provide this information because of the IP concerns. So what we can do is we can use a 3D scanner. As you can see from this slide, we can scan the object and create a CAD model of the object. Current technologies are quite successful, and that helps us to generate the exact shape of the particle. So an example is given in here. What we can do with this, or what we can analyze or design. Basically, a couple of examples from my projects are given in this slide. So what we can do is we can analyze the performance of a moldboard plow. So how a moldboard buries the topsoil. As you can see here, this is the test results, and these are the computer simulation results. These are quite similar. And furthermore, we can analyze for example, the schema of the moldboard plow. As you can see here, the topsoil burial is analyzed in this graph, and the blue one is a moldboard plow with a schema, so this small tool, and the red one is a moldboard plow without a schema. So what happens in here is basically the schema gives us better results. This is what we expect from the test results as well. We can compare DM and test results to improve the disc plow. So in this example, you can see a simulation of soil and disc plow interaction. And the topsoil burial results of the test and the simulation results are in good agreement, in well agreement. Or what we can do is we can analyze the disk openers in cohesive and in sticky and send the soil, so that we can generate or design better tools. In this video, you can see the performance of a rotary spader. If we put some blue sand on top, and after the operation, we can see you can see here the soil patterns. And this is the simulation results. Again, we can simulate this in high accuracy to analyze what actually our machine does. What else we can do is we can analyze the wear, which is an important thing. We can analyze the wear and see how our tools are deforming when they are interacting with the soil. Or we can use this method to analyze the food processing of different machineries. So as you can see here, this customer approach our school and say, we have a problem because this machinery is not flowing the almonds properly. As you can see in here, when we simulated, we got the same result, and doing some modification, we give the right information to the manufacturer so that they can improve their design. Or what we can do is we can do DEM and CFD coupling, so that we can do we can analyze the flow of the particles. As a summary, what we can do with this technology is force prediction, soil movement prediction, tool optimization, basic passive tool motion, and more complex simulation with multi-body dynamics coupling, and some fully designed bed simulations using DM and CFD coupling for modeling erosion and this type of works. Currently, we are working with different companies and universities all over the world with this technology, and so far we have obtained more than 1.5 million Australian dollar worth of grant. So this technology is currently being used by big manufacturers, and I hope that this technology is being adopted by local manufacturers to improve the machinery design. Thank you. That's the end of my presentation. If you have any questions, I'm happy to reply.
Thank you, dear Işgün, your presentation. We can pass the other presentation. The second presentation is determination of the factors affecting livestock enterprises to get animal life. Burak Mat present the presentation.
Thank you.
Thank you.
Ekran geldi mi hocam?
Evet, geldi.
Ben sunumumu Türkçe yapacağım. İlk önce onu belirteyim.
Tabii, buyurun hocam.
Bugün size sayın hocalarım hayvancılık işletmelerinde hayvan hayat sigortası yaptırılmasını etkileyen faktörlerin tespit edilmesini anlatacağım. Bu bizim bir projemizin sonucunun kısaca bir özeti olacaktır. Bildiğiniz gibi hayvansal üretim süreci doğası gereği bir takım risk ve belirsizliklerle karşı karşıya kalmaktadır. Hayvan hastalıkları ve diğer riskler işletmelerde verim kayıpları ve ölümlere neden olarak işletmelerde sermaye kaybı ve zararları neden olmakta. Gelir ve sermaye kayıpları ise sigorta aracılığıyla telafi edilebilmesi işletmelere önemli yarar sağlamaktadır. Bu çalışmanın amacı Türkiye'de yapıldığı iller itibariyle üreticilerin hayvan hayat sigortası yaptırmama nedenleriyle bunu etkili faktörlerin belirlenmesi ve sigortalılık oranının arttırabilmesine fayda sağlayacak çözüm önerilerinin ortaya konulmasına başlamıştır. Araştırmanın materyalini Afyon, Aksaray, Ankara, Burdur, Karaman ve Konya küçükbaş ve büyükbaş hayvancılık işletmeleri oluşturmaktadır. Bu çalışmanın örnekleminde araştırma kapsamında 252 adet işletmeden elde edilen veriler değerlendirmeye alınmıştır. Ve ölçekte değerlendirilirken üreticilerin hayvan hayat sigortası yaptırma nedenlerinin belirlenebilmesi için hayvan hayat sigortası tutum ölçeği geliştirilmiş ve geliştirilen ölçeğin maddeleri varmak söndürme yöntemiyle 5 faktörlü bir yapı elde edilmiştir. Bulgulara gelecek olursak, işletmelerde hastalıktan arı belgesinin olması, mesleki tecrübe itibariyle 5 yıldan az bir mesleki tecrübeye sahip olunması ve hayvancılık haricinde ek gelir kaynağı olan işletmelerin sigortalılık oranında bir artış gözlemlenmiştir. Bunun yanında üreticilerin eğitim seviyesinin düşük olması sigorta yaptırma eğilimini azalttığı tespit edilmiştir. Üreticilerin büyük bir bölümünün gelecek yıllarda hayvan hayat sigortası yaptırmayı planlamadığı ancak gelirinin artması veya primlerin ucuzlaması durumunda sigorta yaptırmayı tekrar gündemlerine alabileceklerini bildirmişlerdir. Bunun yanında üreticilere Tarsim hakkında bilgi derecelerini sorduk ve 252 kişiden 138'inin bu konuda bilgisi olmadığını, 114'ünün de ortalamaya bakıldığında orta seviye bir bilgiye sahip olduğu değerlendirilmiştir. Ayrıca üreticilerin Tarsim hayvanat sigortası yaptırma nedenlerine bakıldığında bu durumda birinci sırayı tarımsal kredi kullanıldığı için, ikinci sırayı beklenmedik sermaye ve ürün kayıplarını önlemek için, üçüncü sırayı üretimde devamlılığı sağlamak ve arkadan hayvan hastalıklarından dolayı ve devlet proje hibelerinden faydalandığım için şeklinde sıralamışlardır. Ayrıca hayvanat sigortası tutum ölçeği soruları 5 faktöre dağıtılmıştır. Faktörlere sırasıyla sigortadan beklenti, sigorta farkındalığı, prosedür ve inanç, finansal faktörler ve masraf olarak adlandırılmıştır. Ölçeğin toplanarak bir ölçek toplam puanı elde edilmesi için ana ve tükey ölçeğinin toplanabilirlik testi uygulanmış ve ölçeğin toplanarak bir ölçek toplam puanı edilmesi için uygun sonuç olduğu sonucuna varılmıştır. Tartışma ve sonuç kısmına gelecek olursak, sigorta yaptırmama nedenlerinden mesleki tecrübe incelendiğinde araştırma kapsamında mesleki tecrübe arttıkça Türkiye'de hayvan hayat sigortası yaptırma eğiliminin azaldığı, bunun yanında hayvancılığa yeni başlayanların devlet destek ve teşviklerinin yararlanması, bankadan kredi kullanımı gibi durumlarda zorunlu olarak sigorta yaptırması gerekli olduğundan yüksek oranda bulunduğu anlaşılmıştır. Bu bulgu hayvansal üretimde ihtisaslaşmanın artması ve sermayenin birikimiyle sigortalı yetiştiricinin daha da yaygınlaşacağı anlamına gelmektedir. Ayrıca sigorta yaptırmaya etki eden faktörlerin biri de eğitim düzeyi ve bilgi seviyesidir. Bu çalışmada eğitim düzeyi düştükçe hayvanat sigortası yaptırma oranları düşmektedir. Zenk ve arkadaşlarının 2010'da yaptığı bir çalışmada üreticilerin sigorta poliçesi satın alma davranışlarının yaşlarına ve eğitim düzeylerine bağlı olduğu bildirilmiştir. Artan eğitim seviyesi ile üreticiler risk kavramını daha iyi ve daha doğru bir şekilde algılayabilmektedirler. Sonuç olarak sigortalılık oranının artmasında düzgün ve sağlıklı bir risk algısıyla mümkün olabileceği anlaşılmaktadır. Üreticilerin sigorta ilişkin bilgi düzeyleri ve sigorta yaptırmaya etki eden diğer bir unsurdur. Araştırmamız kapsamında üreticilerin %54.8'in sigorta hakkında yeterli bilgi sahibi olmadıkları tespit edilmiştir. İç Moğolistan'da yapılan bir çalışmada 500 büyükbaş sığır ve üzeri yapılan işletmelerde işletme sahipleriyle yapılan anket çalışmasında sigorta hakkında bilgi sahibi olma oranının %50.6 oranı tespit edilmiş. Sonuç olarak büyük ölçüde üreticiler kendileri için mevcut fırsatlar ve elde ettikleri faydalar hakkında daha iyi bilgilendirilirlerse hayvanat sigortası yaptırma oranlarının artacağı öngörülmektedir. Araştırma kapsamında gelecek yıllarda hayvanat sigortası yaptırmayı düşünmeyen üreticilerin oranı %66 olarak belirlenmiştir. Sigorta yaptırmama nedenleri işletme gelir düzeylerinin yetersizliği, primlerin yüksek görülmesi, sigorta bilinç ve kültürünün olmayışı nedenler öne sürülmüştür. Şimdi bizim Türkiye'de sigorta yaptıran işletme sahiplerine devlet %50 hibe vermektedir. İlk önce bu bilgiyi paylaşayım. Yani sigorta ücretinin yarısını devlet ödemektedir. Yapılan bir çalışmada üreticilerin hayvanat sigortası poliçesi satın alma kararının yüksek prim fiyatları sebebiyle azaldığı, böyle durumlarda devlet tarafından verilen prim desteği sigorta fiyatını düşüreceği için sigorta poliçe alımını olumlu etkileyeceği bildirilmektedir. Bu yorum araştırmamız kapsamında da devlet desteğinin daha çok olması halinde üreticilerin %83'ünün sigorta yaptırmaya karar verecekleri yönünde bir bulguyla örtüşmektedir. Fakat bunun tersi bir durumda Çin'de domuz yetiştiricilerine yönelik yapılan bir çalışmada sigortada yüksek sübvansiyonlu primin ve devletin güçlü teşviklerine rağmen küçük ölçekli üreticilerin sigorta programına katılmaya etkin bir şekilde teşvik edilmediği bildirilmektedir. Araştırma kapsamında faktör analizi sonuçları incelendiğinde çalışma kapsamında geliştirilen bu ölçeklerin üreticilere uygulaması sonucu ölçeklerin her birinin toplam puanı hesaplanmıştır. Sigortadan beklenti faktöründe elde edilen skorun orta ve üst düzey seviyelerde olmasının nedeni ödenen hasar tutarlarının üreticiler tarafından düşük bulunması ve sigorta kapsamının dar olarak değerlendirilmesidir. Önerilerimize gelecek olursak, hayvancılık sektöründe üreticiler için sigorta önemli bir risk yönetim aracıdır. Böyle önemli bir fonksiyonu yerine getirebilecek olan sigortada yaptırma oranlarının arttırılması, prim havuzunun genişletilmesi iki temel açıdan önem arz etmektedir. Havuzda biriken primin artması ile üreticilere gelecekte daha ucuz primlerle sigorta olanı sunulabilmesi birinci avantaj. İkincisi ise daha çok teminatın güvenceli altına alınabilmesine olanak sağlamasıdır. Katılım oranlarının arttırılmasının ilk basamağı üreticilerin bıkmadan, usanmadan sigorta konusunda bilgilendirilmesi gerekliliğidir. Ve bu bilgilendirme yapılırken bilgilendirici kitlenin eğitim düzeyinin de önem arz ettiği dikkate alınırsa eğitimli ve genç nüfusun da üretim zincirine dahil edilmesi bu konuda belirli bir başarının yakalanacağını söylenebilir. Diğer bir önerimiz ise genel olarak hayvancılık sektöründe üretim yapan kesimin gelir ve refah düzeyini yükseltecek politika ve girişimlerin sigorta yapılma oranında artırabileceği açıktır. Sigorta yaptıran üreticilerin bunun hasar tanzimi dışında diğer uygulamalarda da avantaj sağlamaları, destek ve teşvik puanlaması gibi veya ödeme sistemlerinde poliçe ve prim üretiminin sisteme katkısının geri dönüşümünün sağlanabileceği uygulamalarla faydalı olabilecektir. Teşekkür eder, saygılarımı sunarım.
Teşekkürler Sayın Bırakmak sunumunuz için. The next presentation will be presented by Faraz Jordan Pave. The title of presentation, estimation of wheat water footprint based on Kuru and Admera grid datasets. Okay, you can start.
Hello everyone. Can I start? Okay, hello everyone. My name is Faraz Jordan Pave, and it's a pleasure for me to be here. I'm going to talk about estimation of wheat water footprint based on CRN and AGMERRA graded data sets. Professor Hadi Ramazani and Ms. Aisha Karkan are the two other authors of this study. Well, the lack of data in space and time scale may be a great challenge to water resources managers. The number of synoptic stations and their accuracy may not be always acceptable, especially in some regions that there are no synoptic stations. By the accurate estimation of weather and climate parameters, land use plan can be more efficient. On the other hand, there are satellite and subsequently the remote sensing techniques which provide a wide range of locally, regionally, nationally, and globally data with the minimum time and price. These data can be used in many fields such as agriculture and natural resources, flood degradation, drought, climate change, soil and air pollution. And especially in this study, we are focusing using these data on crops water requirements. The first time the concept of water footprint, as it is shown as WF, was introduced by Hoekestra in 2003 as an indicator of the allocation of freshwater resources to different sections of production of a process. Since then, many studies was focused on this concept. Simulation models have been developed recent years, especially in estimating the water requirement of crops yield and other crops parameters. Despite huge progresses on them, they have several issues such as highly requirement of input data and information about the crop growth of specified locations of each crop. In 2009, aqua crop developed by FAO, which addressed these limitations. It was a multi-crop model which provides a good balance between robustness, simplicity, and output accuracy, which can be used for large number of crops. In this study, two data sets were used to estimate the WF of maize in the Kazvin province in Iran. Results were evaluated by the synoptic station in the province. Data from datasets and synoptic station were used to calculate the WF parameters. The study area of this study was the Kazvin province. This is the location of this province, and it is the area of this province. The Kazvin plain is located in this province, which is the largest plain in the Salt Lake Basin with the largest cultivation area of various crops. The climate of this province is arid to semi-arid, and it has relatively warm summers and cold winters with 14 degree of Celsius temperature and 300 millimeters mean annual precipitation. In this plain, wheat, barley, corn, maize, alfalfa, tomato, and canola are the main irrigated crops. According to Agriculture Jihad Ministry, 144,000 hectares of land under cultivation and 315,000 of tons production per year is dedicated to wheat. And this is the location of the province in the country. The concept of the WF consists of two elements, which are the blue and the green WF. The blue WF is the volume of water which is used in the production of crops. It is also known as net water requirement. On the other hand, we have the effective rainfall, which is stored in the soil and supplies crop water demand in the green WF, which is known as green WF. The two elements are determined as below, and this is a table to help us finding the parameters. In this paper, data from the 30 years of two data sets were used to estimate the WF parameters. These two data sets are CRU and AGMERRA, and these are some features of these two data sets. In this study, in order to compute the actual evapotranspiration, the aqua crop model version 5 was used. This model was introduced by FAO, stimulates yield and biomass in relation to the water available to plants introduced by Durenbos and Kassam empirical relation. What we have done in this paper is that we gather data from the synoptic station, we gather data from data sets, then we calculated the weather parameters by the aqua crop model. After that, we calculated the WFs, and finally we found out the relation and the efficiency of this relation between the data sets and the synoptic station in the province. The amount of indexes and the proposed model for the CRU data sets for both the blue and the green WF are presented as this table. As you can see, the amounts of R squared, RMSE, NRMSE, and maximum error are demonstrated here. And at this table, the Y is the proposed model. According to the results, you can understand that the proposed model for the green WF is much more efficient than the blue WF. Similarly, the amount of indexes and the proposed model for the AGMERRA data sets for both blue and the green WF are presented, and these are the amounts of R squared, RMSE, NRMSE, and ME for both the blue and the green WFs. And according to this table, you can see that the AGMERRA data set is more efficient for the green WF than the blue WF. So in conclusion, we can say that the CRU dataset is much more efficient in estimating the WF than the AGMERRA dataset. Also, we know that the proposed model for the green WF is more efficient than the blue WF, and the AGMERRA is more efficient for the green WF than the blue WF. This paper suggests more studies on using data sets in agriculture management. Here are the references used in this study, and thanks for your time.
Thank you, Mr. Pahal, your presentation. The next presentation is the importance of animal production and its contribution to Somali economy. Hamza Osman Elmi will present this presentation to our. Yes, you can start.
Thank you, dear teacher. I think everyone is able to see my screen, right?
Yes.
Thank you, dear teacher, for giving me this great opportunity in order to make a presentation with the title of the importance of animal production and its contribution to the Somali economy. My presentation contents will be, first of all, I will start with the livestock sector in Somalia, then I will explain animal production and products for animals. Then I will share with you the livestock export in Somalia, then I will conclude my presentation. First of all, before I present my presentation, let me start with to give you a brief information about Somalia. Somalia is located in Horn of Africa. Somalia is bordered by Djibouti to the northwest, Kenya to the southwest, the Gulf of Aden to the north, the Indian Ocean to the east, and Ethiopia to the west. The population of Somalia is 15 million, and the climate of Somalia is tropical. The religion is Islam, and all people are Muslim 100%, and the independence date is 1st July 1960. The language that local people speak is Somali, and the capital city of Somalia is Mogadishu. The livestock sector comprises different types of animals which are important in the sector. The most common Somali animal types are goats, sheep, cattle, and camel. However, these animal types are raised mostly in the rural areas. Despite the conflict and instability that has been witnessed in Somalia over the past 2 decades, the livestock sector has continued to be the main economic activity. In the rural areas, the rudimentary source of the people's livelihoods are the raising and the production of animals. However, the nomadic pastoralists raise and produce different animal species under extensive production nomadic system. Somali pastoralists are subsistence families that rely on livestock as source of income and food. Pastoral communities make up around 60% of the Somali population. Their livelihood mainly depends on herding livestock, good rains, and pasture. The contribution of livestock sector to the GDP of the country is 40%, while the surface is 33%, and agriculture is 20%, and the industry is 7%. The pastoral-based Somali livestock sector is estimated to directly employ more than 55% of the country's labor force and to provide indirect employment for another large segment of the labor force along the livestock value chain. Here is the estimates of total number of livestock population in Somalia from 2007 to 2018. In 2007, Somalia had 7 million of camel, 12 million approximately of cattle, 11 million of goats, and 11 million of sheep, with a total of 35 million of animals. From 2007 to 2018, number of camels has increased by 3%, while the cattle has decreased by 2%, and the goats has increased by 1%, while the sheep are decreased by 9%. Now I would like to move on animal production and the products of animals. Animal products obtained in the livestock sector in Somalia are mainly milk and meat. These products are processed and it's used freshly. The most of the products are produced by the nomadic families in the rural areas of the country at subsistence level. A growing population in Somalia needs to be fed with the nutritious, safe, and affordable animal products such as meat and milk. Animal products provide an excellent opportunity for livelihood diversification, income generation, and employment opportunities in Somalia. Milk production in Somalia is produced under traditional nomadic production system and are sold and consumed freshly through the local markets of the country. However, the total amount of milk production is limited and milk yield per animal is low. Somalia has produced 2.4 million tons of milk in 2018. The production, collection, and the marketing of milk provide employment and income for people in both rural and urban areas, especially women who traditionally dominate in a trade of milk. Milk is a major food source for pastoralists who tend to increase their home consumption during the lean dry season. It also makes a contribution to the nutritional intake of the rest of the population. Here is the share of milk production in Somalia by animal types, and the large share represented by camel milk, which is 45%, where the sheep milk and goat milk are 17%, and cow milk is 21%. In Somalia, cattle, goats, sheep, and to a lesser extent poultry are raised for meat production. Camels, cattle, goats, sheep are raised in the rural areas, and the poultry is raised by families in the urban cities of the country. The meat industry in Somalia is important for nutrition and food security. Somalia has produced 185,000 tons of meat in 2018. Meat trade is relatively profitable in all urban markets and offers employment opportunities for women who dominate meat production marketing. There is no meat processing facilities across the country, and the local people practice traditional home-cured or sun-dried meat products which are locally known as odka. Here is the share of total meat production in Somalia by animal types. And the large share represented by cattle meat, which is 32%, camel meat 25%, and 21% and 22% sheep and goat respectively. Exports with the livestock sector in Somalia are the largest trading commodity industry and the country's main source of foreign currency. Exported livestock species are camels, cattle, goats, and sheep. The largest livestock export market is Saudi Arabia, where Somali live animals are exported during Eid al-Adha. On the Arabian Peninsula, there is strong preference for Somali livestock because there is similar genetic characteristics between shoots in Somalia and shoots in the Gulf. Also, animals in Somalia have similar body shapes, taste, and cooking properties, unlike Somalia from Australia, New Zealand, Europe, and America. Here is the number of animals exported in Somalia over the years from 2012 to 2017. In 2012, in Somalia, a number of 4.8 of animals are exported, where in 2015, approximately 5 million of animals were exported, and the least number of animals were exported in 2017, which is 1 million approximately. Among exported of animals, 65% of animals are exported to Saudi Arabia, while 18% are exported to the United Arab Emirates, and 6% and 5% are exported to the Oman and Kuwait, respectively. Livestock export creates employment and its source of income to the livestock producers, livestock traders, the government, and the local people involved with the value chain of animal market and trade system. According to the FAO, in 2015 alone, Somali traders pocketed 364 million in exports, and the industry grew 6% annually. In conclusion, the livestock sector in Somalia has significant potential in terms of the national economy and the livelihood of a significant majority of the country's population. The livestock sector contributes 40% to Somalia's gross domestic product. In addition, the sector is almost the only sector that provides foreign currency to the country through exports. I would like to give some recommendations to the government in order to improve the production of the sector. The development of the livestock industry in Somalia faces with fundamental problems. However, there should be sustainable solutions should be taken to address the problems of the sector. The government should invest heavily in the livestock sector that provides economic growth in Somalia. The necessary government agencies that can support the livestock sector must develop at a sufficient level. The large-scale animal enterprises should be established in the livestock sector and should be expanded through the country. In order to produce adequate levels of meat and milk in Somalia, crossbreeding studies should be carried out by importing breed animals. And in order to increase productivity in animal production and to ensure adequate and balanced nutrition, the structure of the animal husbandry production system should be improved. Thank you. That's all of my presentation.
Thank you, dear Elmi, for your presentation. The last presentation is cardiological features of conifers in the conditions of anthropogenic pollution in the Bishkek. Mehmet Aliyeva will present this presentation. Okay, you can start presentation.
Hello, everybody.
Hi.
My name is Mehmet. I'm a research assistant at Kyrgyz Turkish Manas University. Today, I want to tell you about cardiological features of conifers in the conditions of anthropogenic pollution in Bishkek, Kyrgyzstan. So, purpose of this study was to provide cardiogenic study of the negative impact of the Tianshine spruce and Scots pine as a result of anthropogenic and technogenic pollution in Bishkek. In this table, we can see chromosomal abnormalities in populations of Tianshine spruce in Bishkek city and in the ecologically clean Kegeti Gorge. We were able to produce 60 pieces of roots from seeds we took in Bishkek and 54 seeds from Kegeti Gorge. So number of abnormal cells were 43 in pieces, or 4.95%, and in Bishkek and 5 pieces in Kegeti Gorge. Also, we were able to see number of abnormal cells in pieces and in persons and types of metaphase anomalies. But I will tell about them later. So, mitotic pathologies in the dividing cells of the tanshine spruce growing in the conditions of anthropogenic pollution in Bishkek. You can see the pictures here. So in A picture, you can see single chromosome breach. And in B picture, you can see double chromosome breach. In C, you can see group chromosome breach. And in D, it's a chromosome breach rupture. It's all of them are pathologies for the cell. You can't see them in normal cells. Also, we can see the ring chromosome and B chromosome in meristematic cells of the tanshine spruce. Cytogenetic abnormalities of meristematic cells in the tanshine spruce, A and E, are chromosomal fragments. B is escaped chromosome, and C is residual chromosomes. D, multipolar mitosis. F is metaphase plate in the chromosomal plate. There are abnormalities in tanshine spruce cells that we observed in Bishkek city. Also, we see the chirological features of Scots pine. The number of abnormal mitotic cells in common pine samples collected in Bishkek was 1.72%, and in samples collected in the Kegeti Gorge, which we can think as ecologically clean area as a control zone, were 0.46%. So we produced 45 pieces of roots from seeds in Bishkek city and 41 pieces of roots in Kegeti Gorge. The total number of cells examined were 926 pieces in Bishkek city and 854 pieces in Kegeti Gorge. So 16 of seeds in Bishkek city were abnormal, and only 4 cells in Kegeti Gorge was with abnormalities. Also, we can see here types of metaphase anomalies in these cells, and most of them were some fragments of chromosomes and multipolar mitosis. Let me show you the pictures. Fragments of chromosomes in meristematic cells of Scots pine, here and here. Mitotic disturbance in the cells of Scots pine grown in Bishkek under conditions of anthropogenic pollution. A, escaped chromosomes. B, remaining chromosomes, here. C, chromosome fragment. And D, multipolar mitosis. All of them are pathologies. So, result of the research shows that the tanshine spruce and Scots pine grown in Bishkek are sensitive to atmospheric pollution and can be used as an object for testing for anthropogenic and technogenic pollution. Thanks very much for your attention.
Thank you for your presentation. We can finish this session, but there are no questions delivered by me to me by WhatsApp. Is there anyone want to ask a questions to presenters? No. Okay, so we can finish this
Thank you
session.
very much.
Thank you. I would like to thank for presentations and valuable information. I wish all of you good and healthy days. See you.
Thank you.
Thank you.
See you. Goodbye.